I'll bet y'all thought I forgot about you. Oh, God. Goodness gracious. Yeah, 1, 2. Wait a minute. How long have I been streaming? Huh. I didn't even know that. Man, I hope you guys didn't see something I didn't want you to see. Alright, something's wrong with my cameras. Yeah. That one's not working. That one's working. And now that one's working. Huh. I do not know why that was not working before. Weird stuff, huh? Well, sometimes I do drop my drawers when I'm putting my microphone on. So I have to be careful which camera is live, you know? So let me switch to that camera, and I'm going to walk off camera for just a moment. Alright, so either my battery is dead or my switch has given up the ghost. Oh, that battery's very dead. Check 1, 2. Hello, 1, 2, 3, 4, 5. There we go. Yeah. All right, that should be a little better. No, the rocket is not going. I am heating my lab with my Bitcoin miner. It's 67 degrees in here. I don't know why I bothered repairing this microphone head. I'm never going to use it for anything. Oh, I don't know. Just the junk collector in me. So yeah, anyway, this afternoon I took a ride over to Harbor Freight, picked up another free digital multimeter and a few small hand tools to rebuild the toolkit for my bicycle. Got a 3mm Allen key, a 5mm and a 6mm, a crescent wrench, and a handle with a Phillips and a straight blade screwdriver. That's my my basic bicycle toolkit. Now I just need another pouch for it to carry it, because I lost the whole shooting match the last time. Anyway, for those of you who are up to speed, the induction heater is coming out of hibernation. I have decided that the capacitor that I am buying, which is bigger than I originally thought. The capacitor is actually 4 inches square by 2 inches high. And to put that in perspective, yeah, that's pretty big. That's almost as big as my boxer fan and about twice as tall. But thankfully I won't need this fan. How will it fit? Well, let me switch camera angles here. The coil assembly will be roughly the same, and it will fit. It should fit between these two copper tubes. And it will be water cooled. So the capacitor will sit kind of like this, just above the copper tube rails, in pretty much the same position as my capacitor bank is right now. The coil is going to be rewound. It will have slightly higher inductance, be a little bit bigger in diameter, and have longer stems to these couplings here so that they can extend through the back wall of the glove box. My overcurrent protection was a success. This is my reset button for the overcurrent protection. So it should be fairly impervious to short circuit conditions. That's my hope. Does the cap have plumbing already for the water cooling? No, it does not. I'm going to have to make 2 manifold plates, one for each side of the capacitor. And I can't really do that until the capacitor arrives, because the cooling tubes on the manifolds are going to have to clear the mounting bolts. And I'm not quite sure exactly where the mounting bolts are going to go. But I will be using 2 sections of 1/2-inch pipe with sections of 3/8-inch copper pipe running in between them, with holes drilled in the 1/2-inch, and then soldered to the copper plates that will be bolted to the capacitor. And it will be tied in with the water circulation plumbing of the coil, and the whole thing will be water cooled. So it should run pretty much continuous duty. Oh no, 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 no. I don't have the room inside the glove box for the whole induction heater and the experiment. Forget it. No, 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 no. Just the coil. Yeah, so is the cap normally air cooled? The cap is normally conduction cooled. So whatever you can use to conduct the heat away is what will take it away. If you had heat sinks with a lot of forced air cooling, that would work. I would just rather tie it. I would rather tie it into the water system, because I already have a water system to tie it into, and it's quieter. So yeah, I guess I can go about breaking this down a little bit, huh? Or maybe I should, I don't know. Maybe I should sell this one. I really can't use this. I should probably just sell it. How much you guys think I can get for this? Minus the transformer. Actually, I'll throw in a transformer, but not this one. Steampunk. All right, old fart that I am. I have to look up what that term means, because I have no idea. Steampunk. A genre of science fiction that has a historical setting and typically features steam-powered machinery rather than advanced technology. Okay, so now I'm ready to say, fuck you. Oh wow, I guess I insulted him. Let's see. Have you seen the induction heads that levitate? Yes, I have seen it. You just have to make it in a cone shape. I will not be doing that. No, just problems with the network. Oh, okay. Comcast out in California, huh? I was thinking about $50. I don't know. I spent way more than $50 just in the capacitors alone. Actually, no. No. That's about right. I probably spent about $50 for the capacitors. Yeah, I've got $50 in the capacitors. The fittings. The fittings are $3 or $4 a piece. So say 4, 8, 16, $20 worth of fittings. Another $5, $6 worth of copper. I've got $75 tied up into this. Easy. You never get back what you... Hey man, what about engineering costs? This is a prototype, you know? Engineering prototypes always cost more. Plus the transformer, that's right. Plus the transformer. Which reminds me. I mean, it's good for about a kilowatt continuous. I was running it at 1.5 and was running into overheating problems. But oops, whoa. It's good for an honest to goodness kilowatt. Oh yeah. I could sell it with this transformer here. Is that the same core? No. Yeah, I should do a video. Get to use my wrench the first time. So this is what I did to my wrench. I don't know if I have the... Yeah, here it is. In order to make it fit into a small tool bag, I chop it down from a 6-inch crescent wrench to a 4-inch crescent wrench. Loungeuser.pcconnect.de. Make an update video, offer stuff for sale. Yeah. Yeah. That's a good idea. Oh, by the way, I checked the brakes on my car this afternoon, and I've still got a good 10,000 miles on the brakes, so I was happy about that. Don't have to replace my brakes just yet. Yeah, those aren't the same cores. I do know that this core worked. I was just concerned about saturation if I was going to go higher than 1.5K. So anyway, this one does work. So yeah, Santa's sleigh. Ho ho ho. All right. So I still don't have the capacitor in hand. Got nothing else to do on the glove box. Trying to think of something to entertain you guys, but I'm running out. Open to suggestions. What else do you need? Gas. Yes, I need a vacuum pump. I need the argon tank and some gas and a regulator. I also need some ceramic bowls. Let me see if I can find a YouTube video where thought you had the vacuum pump. I have a vacuum pump, but it's rather crude. It will only pump down to a 90% vacuum, which is 27 inches of mercury. I am looking at a vacuum pump. Yep, you did. What was the last thing you heard me say? %. Okay. Yeah, the old vacuum pump that I had is really an antique paint sprayer, and it's not designed to be a vacuum pump. It only produces a 90% vacuum, 27 inches of mercury. And the pump that I'm looking at on eBay will pump down to 75 microns, which is a 99.7% vacuum or something stupid like that, which will greatly decrease the amount of time it takes for me to transfer sample pieces in and out of the glove box. So it's about $60. And with the savings that I am realizing by purchasing the Cornell Dubilier equivalent of the Salem capacitor, I'll be able to afford it, and some gas. So all I need is the argon tank and a regulator, and be pretty close to starting the experiment. I mean, for real. Let's see. What was I going to say? I forget. Oh, so this is the link you said you couldn't share with me, huh? All right, let's take a look at this. I see a picture of a boat in front of a restaurant. Please tell me this is not what you want me to see. Please link from TV broadcast. All right. Well, I see a link at the top for live TV. This looks like TV Guide in the United States. Oh, come on. What is this you're sharing? All right. Let me show you what I'm seeing, okay? This is the link that you just shared with us. What is this? A video of a boat sitting on dry land in front of a restaurant. Seriously? Anyway, all right, so I found the transformer core. That's good. My youngest daughter has a friend. Please click the button, play video. So Z, you said got cash for cap, vacuum pump and gas, tanking regularly, but still need some cups. I still need cash for the tank and the regulator, and I also need some cups. Yeah. Hold on a second, let me look at this video. "26 minutes and 52 seconds. No, I'm sorry there, Gainhoffen, I don't have time for that. I looked into tank rentals. It's not worth it. You have to lease them on a yearly basis. Anyway, what was I saying? Oh yes, I was looking for a video. Hold on a second. Let me bring up the video that I was looking for, and you'll see where I'm going with the crucibles that I need. I think I put it in my favorites. Now I have to change camera angles so you can't see me type in my password. There we go. Here it is. Actually, I'm going to play this for you. All right, so check this out.
My name is Deborah Schlegel. I work at the Ames Laboratory. I'm in the single crystal section, and our group works to develop ways of growing single crystals of metals and alloys. A single crystal is different than just ordinary materials in that the atoms have long-range order to them. So the atoms are in rows and columns that extend through the whole material. Scientists are really interested in getting single crystals of materials so that they can measure the true properties of the material. So they don't want to worry about impurities or defects. So the furnace we acquired is a Bridgman furnace. Bridgman is a method by which crystals are grown. And so here I have an ingot. So the whole thing is molten, but the tip is colder. And so the idea is that it will solidify first in the cone, and then as we withdraw it from the heat zone, that single crystal will be propagated through the whole ingot. Some of the classes of materials we're working with are actuators and sensors. The actuators and sensors are in a car. They can be in many different places in the engine, giving you the feedback of the engine as you're driving. Ames Laboratory has gained a reputation for being able to grow high-quality single crystals, and so we're just expanding upon the great science we've already done here at Ames Lab. My name is Deborah Schlegel. I work at the Ames Laboratory.
All right, so here's what I want you to pay attention to. In this process, what I need to grow a single crystal of the alloy that I'll be making. And the process that they use right here, okay? This process, this is the crucible that I need to create the alloy. And this zone right here is the zone where the induction heater will be heating the material. This zone here is what they call the cold zone. I'm not sure how they achieve the cold zone in this particular furnace that they have, but I can tell you how I intend to do it. This area here will be the induction heater. This area here will be an area outside of the induction heater. So what I'm thinking is a non-inductive shroud around the crucible that I can lower slowly through the induction coil, and perhaps a forced air stream coming across the tip at the base of it as it exits from the induction coil to cool at the tip first very slowly in the presence of a permanent magnetic field, so that I align the molecules as they solidify coming out of the molten state, and then let them continue. Let me mute this so that you can see it and get an idea what I'm talking about here. Where the hell is it? Shit. Speed. Here we go. 0.25. So let's back it up. This right here, this what she is holding in her hand, this is the crucible, or a type of crucible that I'm going to be looking to buy. All right, so here's the crucible filled with the molten metal, and they show it riding slowly down through. So what I'm thinking is a some sort of threaded rod assembly at the top that slowly feeds it down through the induction coil and across a forced air stream coming left to right to solidify it, so you end up with the single crystalline formation inside the crucible. Let's see. Is this what you were trying to do? Yes. Basically what Z is wanting to do similar. How do you get the tip? You have a molten mass. Oh, okay. The crucible has the shape. That's correct. The crucible has the shape. Let's see. Z. You could have dry ice surrounding the crucible maybe as cold air sinks. Possibly. Possibly. But it might fracture. Well, you know, that's a chance I'm going to have to take. And obviously, they are exposing the crucibles to very high temperature extremes. I'm going to say that it should be able to withstand these temperature extremes, so long as they are applied uniformly. Shubis has been awfully. Damn it! All right, I gotta move this this wireless mic transmitter so that I don't, so that my chub doesn't drape over the switch and turn it off. Oh well. My last comment was Shubis has been very quiet. What's going on, Shubis? How come you're so quiet? That button is very lazy. Someone has had that idea. Give me a minute to find it. You could inject compressed air into the vertical cylinder to control the crucible. Wow, that would be tricky. No, sorry. I like the threaded rod idea better. That's not even my evil laugh. uh, my evil laugh sounds best through a Fender Reverb. I'll let you hear it one of these days. Maybe on Halloween night. No, sorry. That was just a preview. You want a link to that vid? Hold on a second. Solar radiant energy and the... Did you spell that correctly? The electronium battery? That's the name of the document. Okay. I will search for it now. newenergy.org. This book is unique and it's places blah, blah. Cosmic Energy and Nikola Tesla, Power of the Atom, Solar Radiation, Storehouse, Wavelength and Harmony, Man's Use of Electromagnetic Energy. So what's the conclusion? Hold on a second. I see something about a crucible in here. That word just jumped out at me. The crystal will be grown when its crucible is pushed up entirely into the upper heat chamber. Just shut off the heat and allow it to cool gradually over a period of hours. All right, I'm looking at it now. Oh, I was able to read this anyway. All right, you want me to save it? What in this document specifically do you want me to see? It will help you in the end. Okay. All right, I will try to make time to read it. It's not a very long read, obviously. He creates a metal single crystal. All right. Yeah. And he's allowing the metal crystal to create itself, which is fine. By a slow cooling process. And that would probably work, because the tip would cool the fastest. So the next thing I need to concern myself with is shopping for crucibles. And then figuring out how I'm going to lower it through the induction coil. Well, you see, he seeds it. Who was talking to me about seeding of a crystal? You create the seed at the tip of the crucible. Once the seed exists, then the rest of the crystal forms on top of the seed. But there has to be a single point of formation that everything else forms on top of. That's where the shape of the crucible becomes crucial. Yes, he goes into the details. All right. Well, in that case, let me save it to my main server as well. And when I go back up to the house, I will read through it tonight. Alright, how do I file this? I guess I'll file it under non-Julian magnetostriction. Electrinium.pdf, there we go. Its purpose is to align the molecules to form an electret, but wax loses its charge due to the softness of the material. So he comes up with a now to do it with a metal, so the molecules cannot move out of alignment, and create a dipole rod that can be sliced up into batteries. Huh? Interesting. That sounds like something. What's his face? Why can't I come up with his name? Probably because it's late. God, what the hell's his name? Russ did a video with him. Looks like Stephen King. What's his name? Hutchison. Sounds like something John Hutchison would be interested in. Bye-bye. I guess they have trolls in Germany too, huh? So how many of you guys are entering the Pulse Motor Build-Off this year? I am so glad I'm not being asked to judge. Larry Black. Wow. I'm as surprised to see you as you are probably to see me. Oh man. Yeah, we're getting back to some serious business pretty soon. It's going pretty well, Larry. It's going pretty well. Can't complain. Been a busy summer. Highly distracted. I will be doing my usual weekend thing tomorrow, however. Today was rainy and cold, but tomorrow's supposed to be a pretty nice day, so obviously I will be taking the bike out for a ride again. Ooh. Huh. That's good stuff. Let's see here. Yeah. I don't think I'll be making my own crucible. Ooh. That would be kind of tough. Because the induction heating coil is the only part of the induction heater that will be inside the glove box. The capacitor and the induction heater electronics will all be on the outside. So the induction heating coil has to enter through some fittings on a sealed plate at the back of the glove box. I won't be able to raise or lower the coil. It will have to be dropping the crucible through the coil. Stepper motor, yes. That's my thought. Stepper motor on a lead screw. Z don't have some bad Chinese. I sold it. Got good money for it too. No, I don't. I don't. But I have 3 Arduino controllers. So, yeah, you do. You give me some good laughs. Step. Depends on where you place it. Boy, that's really good Sprite, you know? Wow. Tinfoil Hat Society. Don't get me started. Can you use heat-proof filament of some kind to raise or lower through a tiny rubber? What? Let me reread that. Can you use heat-proof filament? Oh, I see what you're saying. Possibly. Possibly. That's not a bad idea. I could even have a weight or a spring on the bottom to keep the filament taut. That's actually a very good idea. I will consider that. I will consider that idea. Heat rises in any chamber. Argon can be heated just like any gas. Which is why I will have, and I forgot about this, a can't think of the name. Starts with a P. Shit. I must be more tired than I think. I think I'm going to call it a night. But I want to thank everyone for their input tonight. A lot of good discussion going on here. I love the collaboration. And yeah. Could you hook up induction heater coil in multiple sections and just... No. No. Sorry. The induction of each coil would be too low. Good idea. But, yeah. Anyway, I'm going to call it a night. Maybe I'll get on the ham radio and make a couple of contacts before I call it a night altogether. I probably will not be on tomorrow live. Maybe tomorrow night. I don't know. Anyway, tomorrow afternoon I'll be out riding on the bike trails for sure. I don't know if I'll do close to 60 miles like I did last weekend. That was pretty rough. But it was fun. And yeah, I'll talk to you guys later. Anyway, good night everybody. Thanks for sharing all your ideas. It's been a wonderful session. And we'll do it again.